Welcome to another episode of the MPP Solar Training videos. In this video, today we'll be talking about grounding, a very important safety aspect of your system. Do I need to ground my inverter? And how? Let's first talk about why we need to ground. Grounding simply is a safety process that prevents electrocution when we're handling electric or electronics equipment. In a normal situation, we don't need to worry about this because electricity in an AC circuit just travels from one point and then back on another path, completing a closed circuit. But when ground fault occurs, electricity strays through an unexpected path to ground, which can cause catastrophic result, much like what happened to this unfortunate man in the photo. Things, of course, could be a lot worse, which explains why proper grounding is very crucial for your safety. To ground your inverter, let's first identify the grounding position. Ground on an inverter is generally just the outermost area on the device or the chassis, as shown here on these arrows. We need to effectively direct a stray current out of the system, and given the chassis is usually made of metallic frame, it conducts electricity, so naturally it would be the perfect point to establish inverter ground. Once an inverter is properly grounded, in a ground fault situation, stray current can then be directed to earth in the least resistance path, and this ensures safety to human operators. On the inverter terminal, you will typically see inverter ground as marked in green. In principle, both points should be grounded. Now that we've covered the basics of inverter grounding, let's talk a bit more on how different applications can affect grounding practice. First, AC input ground and AC output ground on inverter are really both tied to the chassis, and so are of the same electric potential. If you're using inverter without plans of connecting to any AC powers like grid or generators, then you may skip AC input ground and only ground at the AC output side. But if you plan to connect inverter to grid power most of the time anyway, you should definitely ensure both AC input and output sides are both grounded. Second, when grounding a system, it is extremely important to avoid ground loop, which just means having multiple grounding points in the system, as illustrated in the lower half of the picture. Problem with ground loop is that it can easily cause undesirable interference to load. To avoid this, tie up all grounds from your system components and have only a single point of entry to earth, as shown on top here. Next, in the event of lightning, you definitely want to make sure to only ground on the frame part of the PV array so it doesn't affect the rest of your system. Lightning arresters should be installed on the PV side, and this is usually done at the combiner box. Do not use any PV panels that are either positively or negatively grounded by design, which can cause leakage current. Finally, battery normally is not grounded, unless it is encased in a metallic enclosure, which then should be grounded as it conducts electricity. Again, just a reminder, all ground points from various parts of your system should all be combined to a single ground bus that dissipates to earth to prevent ground loop. Thank you for taking the time to watch this video. It has been our pleasure to share this with you, and we hope you'll find it useful. If you like this video, please remember to subscribe and stay tuned of the latest updates.